In this video, we're going to discuss some of the properties of proportion. And so let's get right into it. So the first property we're discussing is invertendo. Okay. And now these are all properties of proportion. So we're starting with the fact that you got four numbers A, B, C, and D, and A by B equals C by D, right? So because we know that they're in proportion, so A by B equals to C by D. Okay. Now what invertendo says is that if A by B equals to C by D, then B by A is equal to D by C. Okay. Now this is pretty easy to see. You can simply just see that you can reciprocate both sides of an equation and its value remains the same. And that's exactly what we've done here. Nothing too complex about this. Next one is alternando. Again, it's just a very fancy name for cross multiplication. And if we know that A by B equals to C by D, then what they've done is they've simply exchanged the values of B and C by cross multiplication, and they've got A by C equals to B by D. Pretty straightforward once again, right? And then the next one is componendo. Componendo is slightly more difficult to see, slightly more difficult to make out what's happening, but nothing too difficult. So if we know that A by B equals to C by D, then it's perfectly valid to add one to both sides of the equation, right? So we can write this as A by B plus one equals C by D plus one. Okay, and now if we simplify this and take a common denominator, we get A plus B over B equals to C plus D over D. And this is our expression for componendo. So if we're given that A by B equals to C by D, that means that the sum of the numerator and denominator by the denominator is equal to the sum of the numerator and the denominator by the denominator. Okay, now dividendo, once again, it's pretty similar. So what we do in dividendo is over here we see that it's A plus B by B. In dividendo, it just becomes A minus B by B. And that, as we saw, we added one here. In dividendo, we just subtract one. So we have A by B equals to C by D. Then A by B minus 1 equals C by D minus 1. Oh, sorry, one second. C by D minus 1. There we go. And now if we simplify this, you get A minus B over B equals C minus D over D, which is what we require. This is our expression for dividendo. Okay. Now we have something called componendo and dividendo, and I would say roughly 95% of the questions in this exercise are based on this. I'm going to write it as C and D. Okay. So in componendo and dividendo, we derived A plus B by B equals C plus D by D. In dividendo, we derived that A minus B by B equals C minus D by D. Now, if we divide this by this, we divide the first one by the second one, we get A plus B by B into B by A minus B equals C plus D by D into D by C minus D. And if you cancel the common terms from both sides, we get A plus B by A minus B equals C plus D by C minus D. And this is extremely important. Just remember this. Sum by difference. Sum by difference. Okay. We'll be using this for nearly all the questions. And honestly, I would go as far as saying that other properties which I mentioned up till now, there'll be no question in the theory part which ever will refer to those questions. I'm just teaching you this because I have seen some questions where some MCQs where they test you on this. For the same reason, I'm teaching you one more thing, and this is called convertendo. I have seen not seen any questions, any PYQ, PYPs related to this, but it's still a good idea to know. So what it does is we know that by simple proportion that A by B equals to C by D, and by dividendo, we know that A minus B over B equals to C minus D over D. Now, if we do the same thing and if we divide both of this equation, first equation by the second one, then we get A by B into B by A minus B equals to C by D into D by C minus D. And we get, if we cancel out the common terms, we get A by A minus B equals to C by C minus D. So let me just quickly summarize everything that we have um, proven here. So we first proved that componendo A plus B by B equals C plus D by D. Componendo is adding. Dividendo is the same, just that there's a subtraction sign. A minus B by B equals C minus D by D. Componendo and dividendo, that's both plus and minus. It's A plus B by A minus B equals to C plus D by C minus D. And convertendo is just a reciprocal of dividendo, if you want to think about it that way. A by A minus B equals to C by C minus D. Okay. So now that we got this out of the way, okay, there is one more. This is there for a couple of questions. So it says that if A by B equals C by D equals E by F, okay, then then A plus C plus E by B plus D plus F is equal to each of these individual ratios. Okay, there are a couple of questions on this, and we'll be solving them. So quickly revise all these properties, and in the next video, I'll meet you with the questions. Now that we've discussed some of the terms that are required for proportion, let's move on to the questions related to these terms. And first question, let me just paste it here. Yeah, there we go. I've tried to pick as many board questions as possible because these are the type of questions you will see in your papers. So let's say the first question. Using the properties of proportion, find x is to y, and they've given to us that x squared plus 2x by 2x plus 4 is equal to y squared plus 3y by 3y plus 9. So, as I said, most of the questions just straight away apply CND. Let's see how CND is applied. So I'm just going to say using C and D, componendo and dividendo. Okay, so what do we know? CND is that A plus B by A minus B equals C plus D by C minus D. So that means that this part equals to my A, this part equals to my B, this entire part, okay? This part equals to my C, and this part equals to my D. Okay, so now that I've gotten this, let's simplify it. A plus B, x squared plus 2x plus 2x plus 4 by A minus B, x squared plus 2x minus 2x plus 4 equals to y squared plus 3y plus 3y plus 9 divided by y squared plus 3y minus 3y plus 9, right? Further simplify this, we get x squared plus 4x plus 4 divided by x squared, 2x minus 2x is nothing, minus 4, right? On this side, we get y squared plus 6y plus 9 divided by 3y minus 3y, 0, and y squared minus 9. There we go. Now, I'm pretty sure you already see like something that clicks. X squared plus 4x plus 4 is x plus 2 whole square. Y squared plus 6y plus 9 is y plus 3 whole square. So let's express it like that. So we have what? Square. X squared minus 4, a plus b times a minus b. Immediately, x plus 2, x minus 2. This is equal to y plus 3 whole square by y plus 3 times y minus 3. This actually has a lot of this factorization and expansion topics which you've studied in previous classes. So we can cancel 1x plus 2 by this. So we get x plus 2 by x minus 2 is equal to y plus 3 by y minus 3, right? You can cancel one of the y plus 3's. And now you can apply another CND here, right? You see it's x plus 2 times x minus 2, right? Remember, we know that CND is a plus b by a minus b equals c plus d by c minus d. Now, some of you may notice, isn't this already in the form of a plus b by a minus b, right? So then where does this come from? So I'm just going to show this in two methods. So let's see method one. This is the method I like to use, okay? Method one. If I consider x as my A, 2 as my B, right? Then it's already in the form of A plus B by A minus B, right? So then if I do then if I do a CND on it, it should return back to its original form, right? So I should just write this as x over 2 equals to same over here, y over 3, right? Now the second method is what is formally taught in schools and what is slightly easier to understand is just apply a proper CND on this. So if you consider the entire x plus 2 as a, so let's erase this thing here. If I consider this entire x plus 2 as a, and I consider the entire x minus 2 equal to b, and this entire thing as c, and this entire thing as d, and now apply c and d, then I get x plus 2 plus x minus 2 divided by x plus 2 minus x minus 2 equals to y plus 3 plus y minus 3 divided by y plus 3 minus y minus 3, right? Then we get 2x minus 4, 2x, sorry, 2 minus 2 is 0. And we get x minus x is 0, 2 plus 2 is 4, equals to 2y by y minus y is 0, 3 plus 3 is 6. And now if we simplify this, we get x by 2 equals to y by 3, which is the same as before. So whichever one you directly spot, I would say in an examination condition, use method 2 because that's how it's normally taught in schools. So teachers will understand it better. So we have defined the ratio of x to y. So x by y, cross multiplication or alternando, as is written in the book, equals to 2 by 3. But do not ever leave your answer like this. Teachers will cut marks. Write it as x is to, oh, wait, sorry, put the ratio sign here. So it's x is to y equals 2 is to 3. And this is what you get your marks for. Okay. Now, let's just quickly see what we've done. We applied C and D once, then we simplified using algebraic identities. Once we got that, we applied C and D again. I showed you two methods for doing it, one shortcut method and one of the formal method. Up to you which one you use while practicing. In an exam situation, I recommend that you use method 2. So now let's move on to the next question. And paste. Okay. Again, another board question. So we have been told that 7m plus 2n by 7m minus 2n equals to 5 is to 3. And we define the value of m is to n. Part 1, 7m plus 2n by 7m minus 2n, 5 by 3. First step, blindly apply C and D, I would say. Anytime you see use properties of proportion to find this, I would say blindly apply C and D. Okay. Most of the times, 95% of the times, this works. So applying C and D, C and D, we have 7m. Again, method 1, people who can see this, if you consider A as 7m, B as 2n, then you can almost directly see that it's derived from 7m by 2n. And over here, you can apply the same C and D logic and get it. Okay. But I'm going to use the formal method. So that like if someone didn't understand the shortcut method, they'll also be able to gather this. So CND is a 7m plus 2n plus 7m minus 2n divided by 7m plus 2n minus 7m minus 2n. Please notice how I always put this in brackets because it's a pretty common mistake that what students do is they will write this as okay, and this is wrong, right? Because it's this entire thing that's getting subtracted, not only 7m. So this is wrong, right? So that's why always put your path that you have to write in the brackets. So because this minus becomes a plus, and that often leads to errors. Same thing over here, 5 plus 3 by 5 minus 3. Okay, wait. On a side note, just something I want to show once. If your RHS is ever equal to 6, okay, what will be the CND of 6? If you were to apply CND on just 6, so then you will always make it 6 by 1, and applying CND on it will make it 6 plus 1 by 6 minus 1. Okay, just wanted to show you that once because it is a doubt some people have, and we'll surely do questions on that as well. So, okay, let's simplify this. 7m plus 7m, 14m. So 14m. 2n minus 2n is just cancelled. 7m minus 7m cancels, and 2n plus 2n becomes 4n. On the other side, we get 8 over 2, which is 4, right? And now divide this part of it by 2, so you get 7m by 2n. See the relation here? If you're ever running short of time, 7m plus 2n, 7m minus 2n, you can just directly write it as 7m by 2n. Okay, so just showing you that. Right, and this is equal to 4. Okay, and we have to find m by n, right? So we can multiply both sides by 2 is to 7. We multiply this side by 2 into 7 into 7m by 2n, and this also at 4 into 2 by 7, right? So you can get your cancelled. You get m by n is to 8 by 7. So your m is to n. Okay, so now again, over here in these questions, if you want to check if you've done it correctly, substitute the m's with um substitute the m and n with the values you found it out as. So let's say over here, okay, let's take a red color pen and do that here. So we got m as 8. We got it as 8 is to 7. Let's substitute m by 8 once. So if I add this as 8 and this is 7, 8 and this is 7, right? So 7 times 8, 56. 2 times 7, 14. Divided by 7 8s are 56. Minus 14. This has to be equal to 5 by 3. Let's see if it does. 56 is 14 is 70. 56 minus 14 is 42, right? And now what is this equal to? 14, right? 14 times 5 and 14 times 3. So yes, it is. Right? Because 14 times 5 is 70. So we proved that, and now let's move on. Let me just erase this bit. Okay. Now the next part is find the value of, oops. Yeah, okay. The next part is we have to find the value of m square plus n square by m square minus n square. So we have to find m square plus n square by m square minus n square. We find the value of this, okay? Right? So now over here, we know that m is to n is equal to 8 by 7, right? M is to n equals to 8 by 7. This is part 2. Now we got an m square, right? So let's square both the sides. So we get m square by n square, right? So if I square both the sides, you get m by n whole square equals to 8 by 7 whole square. And this is equal to m square by n square equals to 8 8s are 64, 7 7s are 49. Now, what's the pattern? A plus B, A minus B. So essentially you have to apply C and D here. Pretty straightforward. So that's m square plus n square by m square minus n square, which equals 64 plus 49 divided by 64 minus 49. And this is equal to 60 plus 40, 100, 113, right? 113 by 15, if my maths is correct. 15, and that's 104, 113. 113 by 15. You could convert it to mixed form as well. But this is our answer. So now let's move on to the next question. Right. Okay. We've been told that, second, yeah. We've been told that x square plus y square by x square minus y square. Again, I'm sure you notice a plus b, a minus b, right? Equals 17 by 8. So we have to find the value of x is to y. Okay, that's fine. Let's do that. So x square plus y square by x square minus y square. By the first method I show, you can directly write this as x squared by y square equals to 25 by 9. Okay, but I'm going to again formally do it as well. So we have applying C and D, applying C and D, right? X square plus y square plus x square minus y square divided by x square plus y square minus x square minus y square equals 17 plus 8 by 17 minus 8. And so that's what? 2x square in the numerator. And x square gets cancelled at the bottom. You get 2y square here equals to 25 over 9. Cancel the 2, so you get x square by y square equals 25 by 9. If you take a square root of both the sides, you get x by y. So under root of 25 by 9. And your x by y equals to 5 over 3. And you can express it in this form as well. Oops. X by y. That over there is your answer. So now, what's the next part? Next part is x cube plus y cube by x cube minus y cube. Part 2, cube plus y cube x cube minus y cube. So now that we've already found the value of x is to y, let's use that here. So we know that x by y equals to 5 by 3. Again, this is looks like it's in the form of, it's a CND, right? But everything is cubed. So let's cube both sides. X by y whole cube equals 5 by 3 whole cube. I hope you understand why I'm cubing both sides. It's because I see a power 3 here. How will I introduce a power 3? I have to cube it, right? So that's what. So you got x cube by y cube equals 125 by 27. And now you're just one CND away. So do a CND here, and you'll get x cube plus y cube by x cube minus y cube equals 125 plus 27 by 125 minus 27, and that's what? 135, 145, 152 divided by 15, 5, and 98. Yeah, 98. And I think this does get further simplified, right? You can cancel by 2, so that's 49 times 2, right? And you can cancel that also by 2, so that's 76, right? Does it go any further? 7 twos are 14. Yeah. Oh, oh, 2 sevens are 14 plus 120. Yeah, okay. I don't think you can cancel more than this, and this is our answer, right? Let's move on to the next question now. So, now let's move on to the next question. Okay, this is slightly tricky. Most people won't get it in their first go, but this is a question that's very likely to come in your papers. Okay, teachers love this question. So we've been told that P equals to 4xy by x plus y, and we have to find the value of p plus 2x by p minus 2x plus p plus 2y by p minus 2y, right? 4xy plus 4. Okay. So now you see 2x here, you see 2y here, but you see 4xy here, right? And again, by now you must be developing some slight feeling of how it works, right? P plus 2x by p minus 2x. If something was done on a CND to get this, it would be P by 2x, right? If you do a P by 2x on this, if you do a CND, you get this. And if on this you do a CND, you get this, right? Or a CND here on this, you get that. See, this is the sort of stuff you should start seeing by now. And once you see this, you know that you somehow engineer a P plus 2x, right? So let me erase this and show you how we'll achieve that P plus 2x and that P plus 2y. Okay. So P is equal to 2x times 2y by x plus y, right? 4xy. Then we want p by 2x, right? So we know that p by 2x equals to 2y by x plus y. And we know that this is first part. And the second part, we can say that p by 2y equals 2x by x plus y, right? So now that we have this, we're to get p plus 2x by p minus 2x, which is just a CND, right? So CND on both sides. But now you must be developing this slight understanding of how a number looks like after a CND has been done on it, right? You can see that it's like a plus b by a minus b. P plus 2x by p minus 2x equals to 2y plus x plus y by 2y minus x plus y. And on this side, we have p plus 2y by p minus 2y is equal to C and D here will give 2x plus x plus y by 2x minus x plus y. right? So, and whatever we get, we have to add both of those, okay? So let's see what this simplifies out to. So 2y plus y, 3y plus x divided by 2y minus y gives a y minus x. And we have to add this, right? So let's just put a plus sign here. Over here, we've gotten what? 3x plus y by 2x minus x gives you an x minus y. Okay. Now the denominators are not the same, right? And what people normally do is a pretty long method. They cross multiply and get a common denominator, and that increases chances of an error. What you can see here is this is y minus x. We're going to get x minus y. If I take a minus side out common, won't I get minus y plus x, right? So now you're getting an x minus y. This can be written as x minus y. So you can write this as an x minus y, right? Because once you open the brackets, you get a minus x and a positive y. So that means that if I multiply both the numerator and denominator by minus 1, I get the same denominator, right? So isn't it just much faster to multiply the top part by minus 1 and the bottom part by minus 1? You get minus 1 times 3y plus x by minus 1 times x minus y. Am I right? So, um, so 1 second, minus 1 times y minus x plus 3x plus y by x minus y. Okay. Now, if you simplify this, you get minus 3y minus 3x by x minus y, right? We discussed that. Plus 3x. Oh, that's 3x. It's 3y plus a single x. Yeah. Plus 3x plus y by x minus y. Okay. Now, if we simplify this, add this, we get 3x minus x, which is 2x, minus 3y plus y minus 2y by x minus y, right? And now if you simplify this further, you get 2 times x minus y divided by x minus y, cancel both, and you get 2 as your final answer. Now there was lots we did in this question. Let's just see exactly what we did. So first, we figured out that p plus 2x by p minus 2x is a CND of p by 2x. Same way, this is a CND of p minus 2y, right? Then we tried to understand how we could get a 2x, p by 2x, and a p by 2y. Okay. For that, we broke up 4xy as 2x times 2y, and we wrote p by 2x is 2y plus x divided by x plus y, and p by 2y by 2x by x plus 2x by x plus y, right? Then we did a CND on them both, and we got two expressions, which when we added, we got 2, right? And we used some pretty cool tricks here to get a quicker answer. We saw y minus x is just multiplied by minus 1 to get x minus y. So we multiplied both the numerator and the denominator by minus 1. And so if we had a simpler calculation to do, and then we had to take out x minus y out common, and we got 2. Okay, let's move on to our next question. Let's now move on to the next question. So we have, yes, you would use component on dividend and find the value of x. So let's just first blindly apply CND. For those of you who remember my trick, you can simply just directly write this as root of 3x plus 4 by root of 3x minus 5, right? Because this is a plus b by a minus b, so you can just write this as a by b. But I'll just formally show you once how you get that so that you get more practice in applying CND to slightly more complex looking equations. So CND, so we can write, so for now, let's say that root 3x plus 4 equals to a, and root of 3x minus 5 equals to b. So it'll be easier for me to show you the CND because root 3x plus 4 is a very big term to write, especially on this pen tab. So that's a plus b by a minus b equals to 9. And I have to apply CND on both sides. We get a plus b plus a minus b divided by a plus b minus a minus b equals to 9 plus 1 by 9 minus 1, because you can visualize 9 as 9 by 1, and then you can just 9 plus 1, 9 minus 1. And then we get 2a by a gets cancelled, so 2b equals to 10 by 8. If we simplify both sides, we get a by b equals to what? 5 over 4, right? Now let's substitute the value of a and b. So a is equal to root 3x plus 4. B is equal to root 3x minus 5 equals to 5 by 4. Okay, so now let's square both sides. We get 3x plus 4 by 3x minus 5 equals to 25. 5 square is 25. 4 square is 16, right? So then if we simplify this further, we can get 3x plus 4 times 16 cross multiplication equals to 25 times 3x minus 5, right? And we simplify this, we get 48x plus 16 fours are 64 equals 25 times 3 is 75x minus 125, right? So now if we transpose x on this side and minus 25 on this side, we get 75x minus 48x, which is 20, 58, 68, yeah, 25, right? No, that doesn't make sense. 27x, yeah. So we get 27x equals to 64 plus 125, which is equal to 189, right? Right? And 27 times what? 7 equals to 189. Let's just verify that once. 27 into 7, 7s are 49. 7 twos are 14, 18, right? So we know that 27 times 7 equals to 189. So we know that our x is equal to 7. X equals to 7. This is one small trick that also I would like to draw your attention to. Over here, actually, if you look at it, squaring both sides is not really necessary. You know that a root of 3x plus 4, using this, you can simply read this as equals to 5, and you can write this as 3x minus 5 equals to 4. Okay, you can just read it. Okay, it's like I know it seems a little bit weird, like how a, but this works. Okay, this trick does work sometimes. And if you want to quickly verify calculations or for some other question, you want to just quickly solve a question, you could look at small tricks like this. Okay, just wanted to bring your attention to this. If you do it this way as well, you get that same answer. So you could square both sides or whatever, and you get that. Let's move on to the next question here. So next question, would again use properties of proportion and solve this. I repeat this, I said this once before, I'll say it once again. Wherever you see, whenever it tells you to use properties of proportion, first thing you think of C and D. Blindly apply C and D. I know in math it's never wisely to blindly do anything, but for this, I can tell you that most of the times this will work. So we've got this. Let's apply C and D to it. So we can say applying C and D, we get x4 plus 1 plus 2x squared divided by x4 plus 1 minus 2x squared equals to 17 plus 8 by 17 minus 8. Okay. Now, once again, quick mental maths required here. Algebraic expression, right? You should directly see this as x square plus 1 whole square, right? x4 plus 1 plus 2x square. Whenever you see a term like this, always try to factorize it, okay? And these are pretty simple factorizations. And also here, questions are pretty similar always. And whenever you have a question like this, you get it as a square divided by another square. So this is x square minus 1 whole square, right? Just minus 2x square. And over here we have 25 by 9. Okay. So yeah, so let's try to simplify this further. We have this, right? So we can write a square by b square as a by b whole square, right? I'm sure you know that. So let's just do that here. We can just write this as x square plus 1 by x square minus 1 whole square equals to 25 by 9. And 25 by 9 is what? 5 by 3 whole square, right? 25 is 5 square, 9 is 3 square. So I just save a step and write this as 5 by 3 whole square. These are the sort of things you should see immediately. Okay. So then we can take a root of both sides, right? It's always safe to square root square, reciprocate both sides. So let's do that here. So we get x square plus 1 by x square minus 1 is equal to 5. by 3. Okay. So you get cross multiply, you get 3 times x squared plus 1 equals to 5 times x squared minus 1. And you get 3x squared plus 3 equals to 5x squared minus 5. Um, Whatever, transpose it, you get 2x squared is equal to 8. And you get x squared is equal to 4. So that x can be equal to plus minus 2. Okay, yeah. So once again, over here in this step, you can save some time in your calculations by just equating this to this and this to this. You'll get the same answer. You don't even have to do it twice. If you just equate this, you get the same answer again, just to save time for any Olympiads or anything that you're trying to give. Some quick techniques. Okay. Next question. So right. Let's move on to the next question now. Again, pretty similar, this question. Let's solve this as well. So once again, C and D, right? Okay, over here, this is a very common question. This comes in lots of different places, lots of different papers, and let's just solve this once. Okay, so once again, first thing when you see a question of proportion, think, okay, how can I apply C and D? And in this question, just apply C and D as usual. Okay, so you have X. Let me just write this one expression once down. Okay, I'm just going to be considering root A plus 3B as capital A and root A minus 3B as capital B for the purpose of just simplifying everything once. So basically the expression that's written is x equals to a plus b by a minus b, right? And once again, you can see the proportionality, the proportion like the C and D form, right? A plus b by a minus b. So most of you by now can directly just say that this is equal to a by b once you do a C and D. And that's what I hope that by the end of this video, all of you can do. So let's apply C and D, right? So x by 1, right? So you got x plus 1 by x minus 1 is equal to a by b, or again, once again, I'll simplify it and make it easier for you. So it's a plus b plus a minus b by a plus b minus a minus b. And this is equal to 2a by 2b, which is equal to a by b, right? X plus 1 by x minus 1. Now a is equal to what? Root of a plus 3b. So let's write that. Root of a plus 3b divided by root of a minus 3b is equal to x plus 1 by x minus 1. So once again, under root of a by b equals to root a by root b. So we can write this entire thing as a root, like a full common under root. So that's root of a plus 3b by a minus 3b equals to x plus 1 by x minus 1. Now we're squaring both sides and we get a plus 3b. If some of you think I'm going too slowly, you can watch the video on 1.5x speed equals to x plus 1 by x minus 1 whole squared. So now you just work this out. So you get a plus 3b by a minus 3b equals to x squared plus 1 plus 2x by x squared plus 1 minus 2x, right? Okay, now over here you've got two choices. Either you apply C and D once more, or you just directly transpose it, cross multiply, and solve it. I will be applying C and D once more so that because it's overall a simpler simplification. So a plus 3b by a minus 3b. Um, it Once you apply C and D, by now you should all know that this is just equal to a by 3b. And at this time, I'm not going to show it because we've done it so many times. Okay, and over here, this is actually a more complex C and D. So let's work this out. X squared plus 1 plus 2x plus x squared plus 1 minus 2x divided by x squared plus 1 plus 2x minus x squared plus 1 minus 2x. right? This is what? A divided by 3b is equal to, if we simplify this, x square plus x square is 2x square, 1 plus 1 is 2, and your 2x and 2x get cancelled. Denominator, we have x square and x square, they get cancelled. That just, yeah, x square and x square get cancelled, 1 and 1 get cancelled, and you have 2x plus 2x, which is 4x, right? You can open this bracket and check. This is what you will get. So now if you further simplify it a bit, you can take 2 out common from here, you get x squared plus 1, and you can take out 2 out common from here, you get 2x, cancel out this, and now you can cross multiply, and you will get 2ax equals to 3b times x squared plus 1. 2ax equals to 3bx squared plus 3b. And what have they asked you to prove? They've asked you to prove that bring everything to one side and prove that it's equal to 0. So let's bring everything to one side. We get 3bx squared plus 3b minus 2ax equals to 0. And that's exactly what they have asked us to prove. Right? Okay. Now let's move on to the next question. We've been given something and we've been asked to prove that x by a equals to y by b. I hope you guys all understood the previous question because this is a very common question that comes. If you want, I can just explain it once more. So what we've done here is we've applied C and D, gotten something, squared both sides, simplified that something, applied C and D again, and then we finally got our final answer. So multiple C and Ds. I would like to repeat once as well. Over here, applying another C and D may not be necessary. You can try and solve it without doing it, and your like terms will get cancelled. But it's faster to apply C and D every time you see this form right here, which is a plus 3b by a minus 3b, or a plus b by a minus b of any form. It's always better to just apply one more C and D because you save a lot of time in your calculations. So now let's move on to the next question. Okay, and once again, I repeat, this chapter requires an extensive use of algebraic identities, so please do revise them. So we've got what? A cube plus 3ab square divided by 3a square b plus b cube equals to x cube plus 3xy square divided by 3x square y plus y cube. Let's apply C and D. So now we get a cube plus b cube plus 3ab square plus 3a square b. I've intentionally written it in this form. You should identify this as a plus b whole cube, right? And divide this, you get a cube minus b cube, a cube minus b cube minus 3a square b plus 3ab square, right? Again, a minus b whole cube, right? Is equal to, again, on this side we get x cube plus y cube plus 3xy square plus 3x square y divided by x cube minus y cube minus 3x square y plus 3xy square, right? And now, if you simplify this, you get a plus b whole cube by a minus b whole cube. I've intentionally written it like this so you can see it. And once again, it should have already been a clear hint when you saw a cube and b cube together that it's some identity. Some identities at play. Same over here, you got x plus y whole cube by x minus y whole cube. I assure you by the time you solve the exercise and finish watching this video, you will become a master at this. So we can take a cube root of both sides of the equation and simplify this out to a plus b by a minus b equals to x plus y by x minus y, right? And what did I tell you? Whenever you see a plus b by a minus b or something in the form of that, apply another C and D, right? And you get, I'll just quickly show it once. A plus b plus a minus b by a plus b minus a plus b, right? Is equal to x plus y plus x minus y by x plus y minus x plus y, right? By now you should know that this simplifies to a by b and that simplifies to x by y, right? And this is equal to a by b equals to x by Well, and there we go. These are some of the trickier questions that you may get in a paper. And there we go. Next question we have. Okay, that's the last question. So with this, all the examples of this exercise come to an end. All the important ones, you should solve the rest on your own, solve the exercise very well, solve the chapter test, and you should be sorted. This is an easy chapter. So get going, and I'll see you with the next video.